So we're gonna start this Zoom session because, well, I promise it's about the same time already. So let's get started. I'm not sure if you guys have any questions on the chemistry bits. Can you just voice out if you got any particular questions that you want to ask? Otherwise, these are all in the tutorial videos already. I don't want to, repeat the same thing which I have cascaded and shown it to you. So yeah, just unmute yourself and just let me know which questions in particular you want me to explain. You don't have to turn on your video. You just have to unmute yourself and shout out if you got any questions that you want me to go through in particular. But all of these I've got its own tutorial videos, so I don't think it serves its purpose if I actually have to go through it with you. So if you don't unmute yourself, I assume you're okay with this particular paper. You know how to spot your mistake and stuff. One of the important thing I can highlight to you is things like, what do you write on your question paper? When I go through the questions, if you go through the tutorials, it's basically about what is impossible, cross it out and improve your chances in this kind of MCQ, yeah? So I think I'll leave this tutorial, and what I'll do is I'll go through this particular set of questions. These are not the entire O-level. These are for the early few topics, very simple ones. That's of matter, separation technique, as well as atomic structure. So all of which are combined science past year paper questions. They just are much simpler and you shouldn't get anything wrong with it. Okay, 10 questions. Let's try and get started. So I already sent this to you via private message, especially for those people who finished a bit earlier. So I sent this in private message because I don't want to overwhelm you with a lot of work in one go. However, when you go through MCQ questions, the first thing you do is do not just treat it as A, B, C, D. It's very important that you can score well in multiple choice question because it's 1 mark or nothing. When you see questions, try to circle and underline it. So water is a liquid. As you heat it to 100 degrees Celsius, as you know, water boils at 100 degrees Celsius. So what's happening is you get H2O liquid and they go to H2O gas. This is called boiling. And as you boil, you will see that your liquid particles, which have a little bit of space in between, and then when they go to gas, they are very far apart, a lot of energy. Okay, so they move faster, they have more kinetic energy because they move around much faster, and that's a result of you absorbing energy because you absorb energy going from liquid to gas, that absorb energy. So they gain energy, it must be gain energy, losing energy is definitely wrong, and then they will escape from the beaker because definitely they move faster, so move more slowly is wrong. As you are boiling, your particle turns to gas, which move faster, so A is the very straightforward answer there. Question 2 is very, very tricky actually, because first of all, they say oxygen molecules. As you know, molecule is not atoms, okay? So as I'm doing these tutorials, I write quite a bit of stuff, but if you're in an exam, your key focus is getting the correct answer, so you don't want to spend too much time, writing a lot of things down. However, you have to scribble down some stuff because when you have time to check back at your own work, you need to straight away look at your own handwriting and you know what you did like half an hour ago or 40 minutes ago or something like that. Oxygen is group 6, so this is the atom. This is the electronic configuration. This is second shell. This is period 2 because that is the first shell. If there is the first shell, there is a second shell. First shell is full, second shell is not full. It's not happy, it's not stable. So what you do is you form covalent bond. You form 2 covalent bonds because you will share 2 electrons to go up to fully fill outer shell. So this is the dot and cross for oxygen. And that is still wrong. That's number 1 mistake with a lot of students. You have 6 outer shell electrons. You use 2 for forming covalent bond. You still have 4 more in your outer shell. So make sure you don't do things like that, yeah? O2 is the formula, diatomic molecules, 2 atoms bonded together. Now at room temperature and pressure, room temperature is 25 degrees Celsius, O2 is a gas. So it's asking you, how does a gas looks like? Do you know oxygen is a gas at 25 degrees Celsius? You are breathing in oxygen at the moment as you are doing respiration. So closely packed is definitely wrong because gas particles are not closely packed at all. They do not vibrate about a fixed point because that is for solid. Vibrate about fixed points for solid. Well, actually, I already crossed out A and B, so I don't even have to check that at all. Loosely packed, yeah, loosely packed means a lot of space in between. Vibrate about fixed point, I did say that it's wrong because that is for solid, so it has to be C there. Okay, so moving on to the next one. This is a very, very tricky one because you have salt and water. As you know, salt is your sodium chloride. Sodium chloride is your table salt. They dissolve in water. They dissolve in water, meaning to say they are soluble. That's how you get salt water. Think about your salt solution, your seawater. This could have been interpreted as seawater. You want to get insoluble salt, does not dissolve. Oh, actually, this is a very, very simple question. Something that dissolves, something that doesn't dissolve. Then this is what you call in Malay, you call it tapis. So this is just filtration because this is insoluble, this is soluble. So what you do is you have a filter paper. So this is the setup, the filter paper. They can ask you to label apparatus, by the way. This is your filter funnel. Then you will have pass through something, and then you will have the solid remains there. The solid is called residue. Residue means whatever you left behind. The thing that passes through is the solution. So the solution is called filtrate. They ask you to label this from time to time. Yeah. So this is insoluble. It will be collected as a solid. This is soluble. It will be collected as the filtrate. It passes through the filter paper. This is in Malay called tapis. So this is a very simple question. Number 4 is a paper chromatography, very popular in your combined science. Make sure you know what's going on. Yellow is pure. So we look at horizontal level. So which one contains yellow? Well, if the spots move up to the same level in the same solvent as yellow, so R contains yellow. So I hope you can see that R contains yellow, T contains yellow. Okay, so it has to be R and T, so C there. Okay, this is what you do on your question paper. If you don't print out the question paper, it's fine, but you have to write something on another piece of paper. Otherwise, if you're just looking at the answer, when you check back the answer, what are you checking? Are you checking that you have filled in the blanks, or are you just checking, are you checking you gotten the answer? Are you checking that there's nothing wrong with your method? That kind of stuff, yeah? Moving on, question 5. So just now it's about pure substance. Pure substance means only one spot. It does not separate into 2 or more things. Here you can see A separate into 1 and 2. So A is impure, not pure. In fact, B is pure because B only separates into 1. C is also not pure, it's separated into 3. D separates into 2 things. That's the idea of chromatography. Different substances have different solubility. Explain why they can be separated, because they have different solubilities. What have different solubility? The solute. Solute refer to each of these substances that have different solubility in the solvent. Solvent is the solvent that you use, the one that move up to carry these dots with it. Yeah. Question 6, the keyword there is a mixture. That is number 1, and it's a 2 elements. It's not a compound. Be careful, not a compound. They want a mixture of elements. All right, so this is a compound. That is a compound because from your lower secondary as well as definitions, 2 or more elements chemically bonded together. A is wrong. That is a compound. 2 or more elements chemically bonded together. D is wrong. They want a mixture of 2 elements. 2 elements. That is element number 1, because even though there are 2 atoms, but the 2 atoms are exactly the same. So element contain only 1 type of atoms. As you know, you can have diatomic molecule. Diatomic meaning 2 atoms bonded together, like F2, Cl2, Br2, I2. like H2, N2, O2, etc., etc. This is also elements, but these are like noble gases because they don't form any bond at all. They are happy with their fully filled outer shell, so they just exist as single atom. These are straight from your bonding topic as well as chemical formula. Monoatomic. Monoatomic is for noble gases. They don't form any bond at all. They just exist as single atom. So here you have one element, two elements, three elements, four elements, but if you look at this is a compound. That is a compound because it consists of two or more atoms bonded together. So really there's only B as your answer there. Number 7 is basically related to what I said. Remember hydrogen gas? Hydrogen only has one electron in the outer shell. So not happy. It wants to form a covalent bond. It shares electrons. 2 electrons being shared is one covalent bond. One covalent bond. And when you have 2 atoms bonded together, that is what you call a molecule. So this is atom. This is just atoms. Here you have a mixture of molecule. So they all consist of one type of atoms only, but this is atom. You want molecules. So you know this is not H2 only. This is H2 only. This is solid. This is gas. They are looking for gas. So a lot of things to look up for. Do not just decide whatever you want to think, but rather read through the question carefully. Question 8 is about atomic structure. Here you have Na+. Plus 1 means it's an ion. It's a positive ion. Positive ions means there are more protons than electrons. Protons have a positive charge. Electron has a negative charge. Plus 1 means atom has lost 1 electron. Atom has lost 1 electron. And this is a metal, so metal lose electron, as you know. Metal loses electrons. Metals are on the left-hand side of the periodic table. Proton number has another name. It's called atomic number. Its identity. Nuclear number is also known as mass number. Is equal to number of protons plus the number of neutrons. So what are we looking for? We're looking for the number of neutrons. That's number 1. The number of neutrons, X equal to nucleon minus protons. So it's basically Na plus 2311. This is how the international notation would look like. It's 23 minus 11, so 12 is correct there. You can use calculator. Please bring a calculator for your combined science exams because you definitely are allowed to use a calculator. Okay, so this is not atom. If it is atom, then overall uncharged, then electron equal to number of protons. But this is a plus 1, so the metal has lost 1 electron. The atom has 11 electrons, so the ion will have lost 1 electron because you kick up 1 electron due to the plus 1 charge. You only get 10 electrons. 2,8, you have a completely filled outer shell. That is why sodium, when they form ion, is Na+. So there are only 10 electrons in this ion. Question 9, we'll just go a bit faster now. So when you have argon, the mass number is also known as nucleon number. The atomic number is also known as proton number. So proton number at the bottom, nucleon number on top. Don't forget that this is an atom. Just now you have an ion. Ion meaning you are charged. Atom meaning you are uncharged. So number of electrons is equal to number of protons because overall is uncharged. Atom is uncharged. So what do we know? We know that this is how you write in the international notation, and this is how question will give you. So there is your proton or atomic number, the definition of which is the number of protons in the nucleus of an atom. So you don't have 22 protons, you have 18 protons. Very, very straightforward there. Nucleon number, as I said earlier, nucleon number or mass number equal to number of protons plus number of neutrons. If you want number of neutrons, then it's mass number or nucleon number minus the number of protons. The top bit minus the bottom bit if you have gotten the international standard correctly. 40 minus 18, do on your calculator, you get 22 neutrons. And that's why the answer is B. and not the other one. Of course, the number of electrons equal to the number of protons based on what I just said, because they use the term atom there. Last but not least in this question, so potassium. Potassium is element number 19. So there's the identity of that particular element. The symbol is K. 19 is the proton number. I'll put on the bottom left-hand side because I'm not writing periodic table. 39 is on the top left-hand side. Now I have neutral atom. Neutral atom meaning not charged. As you know, if an atom is not charged, then the number of electrons equal to number of protons. As the proton have a +1 relative charge, electron has a -1 relative charge. So altogether, what can I say? The proton must be 19 because the atomic number, or the proton number is 19. And then the number of electron must be equal to 19 as well, because overall atom, when you see the term atom, number of electrons equal to number of protons. As for the number of neutrons, it's going to be the mass number or the nuclear number minus the number of protons. I get 20 neutrons. So looking through the statement, 19 electron, 20 electron, 39 CAD is incorrect. 20 neutron is correct. Do not confuse neutron and nucleon. Nucleon refers to everything that lives in the nucleus. It includes protons and neutrons. This is number of nucleons. There are 19 protons. The remaining is neutrons. That's why the number of proton plus the number of neutron give you the number of nucleons. All right, so that's all the time I have for today, and I hope it was useful. This session is recorded. I will be shared with the group chat later on. But yeah, I mean, try to do more on your own rather than just rely on me. But whatever you do, I hope you understand what you're doing. Okay, that's all the time we have today. Thank you for coming, and yeah, have a good day.